Hello class. Today we're going to talk about multi-step inequalities. Okay, so let's begin with our warm-up. So what I'd like for you to do is I would like for you to solve the first two and graph them, and then solve the third one, but don't graph it. So pause the video and answer those three questions. Okay, let's see how you did. So in this first one, we know it's just a simple one step, the first two. Okay, so we're just kind of reviewing what it is I need you to remember about inequalities. Okay, so in this first one here, okay, I've asked you to remember a couple things. One, check out the operation. If it's addition or subtraction, make sure that it's addition. Okay, and then if it's not, then change subtraction to addition next to its opposite, like we'll have to do in this second question here. But in that first one, I've also asked you to look at your look at your coefficient. And in this particular one, the coefficient is a -4. Okay, so if that coefficient is negative, we need to remember that our inequality is going to flip. Okay, so in this first one, I've got to multiply by -4, so I'm going to do a divide by -4, and then I'm going to divide by -4 on the other side. So we end up with x, and then 16 divided by -4 gives me -4. But this inequality right here, because I'm multiplying through or dividing through by a negative, it's going to flip. So instead of being less than, it's going to change to a greater than. Okay, so now we graph this. So we do a quick graph. Just put a 1-inch line, put a tick mark in the middle, put the solution, and we're going to graph the solution set, which are all the values that would make this true. Okay, now because this is just a greater than symbol, it's going to be an open circle. And this says I want all x values that are greater than -4, so that's all the values that are to the right of -4. Now it is always a good idea to check this just to make sure. So as I said before, one value that I like to use if it's part of my solution set is 0. Okay, in this particular one, yes, 0 would be part of it. So I come back up and I plug in -4 times 0. Is that less than 16? Well, -4 times 0 is 0, and 0 is less than 16. So we know that question works. So then we move on to question number 2. Now, question number 2, there's several things that I don't like about this problem. Okay, so we need to do some things with this. Okay, so the first thing I've asked you to do is check out their operation. Okay, so in this one right here, we do have a minus, so I'm going to change that subtraction to addition next to its opposite. Okay, I look at my coefficient. Well, if there's not a number in front of x, then we know that there is a 1, and that 1 does happen to be positive, so we're good. Now, the only other thing that I don't like about this one is that my letter is on the right. Okay, so I would like to move it over to the left-hand side. Now, I told you yesterday there's a 3-step process to do that. Okay, so we take this first side, we write it down. So x plus -8. Okay, and then we take the second side, we write it down. And then we got to pay attention to the inequality. Now this is the only time that I don't want you to talk about an alligator, but I want you to think about it. Think about what the alligator's eating. Okay? In this particular case, the alligator is eating the 15. It opens up to the 15. So when I copy it over down here, I need it to open up to the 15 as well. And now we're ready to solve. Okay, so x plus -8 plus 8 is less than or equal to 15 plus 8. So x is less than or equal to, and then we take 15 and 8 together, and we add them, and we get 23. Okay, so we put one tick mark, put a 23. Now this one's going to be a closed circle, because it does have an equals to, and it says I need all x values that are less than or equal to 23. Well, less than is this side, and the equal to part is the reason why we closed in our circle. Okay, so now we need to work this last one. Okay, the last one, we've got a division problem. Now I'm going to clear this off and kind of move this up a little bit. Kind of move these out of the way. Maybe move this out of the way and move this up a little bit so I've got a little bit more room to work. Okay, so now this one, we look at our operation. It looks good. We look at our coefficient. It looks good. So we just solve it like normal. So x divided by 3 plus 10 plus -10 is less than or equal to 4 plus -10. And I wrote into that line, oh well. See if I can move it out of the way. There we go. Okay, so then I simplify, so my 10s go away, and I'm left with x over 3 is less than or equal to, was it less than? Yes, less than or equal to, and then 4 plus -10 gives me -6. Okay, so now how do I get rid of the the divide by 3? I do a multiply by 3, and I end up with x is less than or equal to, and then -6 times -3 gives me -18. Okay, so in a division problem, what we have to do is we got to pick a value that fits this description, but is also divisible by 3. So x is less than or equal to negative 18. So I need the first number that's less than negative 18 that's also divisible by 3. The first one would be negative 21. And we could use that to check it with. So negative 21 divided by 3 plus 10, is that less than or equal to 4? Well, negative 21 divided by 3 gives me negative 7. So negative 7 plus 10 gives me 3. Is 3 less than or equal to 4? Yes, it is, and it works. Okay? So that is kind of a review of what we've done over the last couple of days. One-step inequalities, and what we did yesterday was a two-step inequality. So today what we're going to do is we're going to look at multi-step inequalities. But to do that, I want us to review something real quick. I want us to review multi-step equations. Okay? Now we know in a multi-step equation that there's 3 basic processes. Step number 1, get your letters on one side. We do that by adding the opposite. Step number 2 is get your numbers on the other side. How do we do that? Add the opposite. And then step number 3, we solve. Okay, so the first thing I see in this problem that I want to fix is I want to take care of this minus. So I change that subtraction to addition next to its opposite. Now I'm ready to start working. So I'm going to move this 9x over to be with this 4x. So I start at the equal sign. And I write 9x plus negative 9x, because that's what I need to move it, plus negative 12. So then I write 4x plus 8 plus, now what was new on this side? The negative 9x. And now I combine like terms. So the 4x and the 9x make negative 5x plus 8 equals, on this side my 9x's go away, and I'm left with negative 12. Now we're down to just a two-step equation. So now I get the 8 over to that side. So negative 5x plus 8 plus negative 8 equals negative 12 plus negative 8. My 8's go away. I'm left with negative 5x equals, and then negative 12 and negative 8 make negative 20. Now I don't want to have negative 5x's. I want 1x, so I divide by negative 5, and I end up with x equaling, and negative 20 divided by negative 5 is 4. And that's how we solved a multi-step equation. Now my question is then, do you solve a multi-step inequality the same way? Well, we found out that with two-step inequalities, we solved them the same way. There was just one difference, one thing. When I got to this line right here, if my coefficient was negative, then I had to flip the inequality. So do you think that's what we're going to do with multi-step? I bet so. So, I said we're not doing this part. Sorry, that was for a quiz that we used to do, and we're not going to do that one right now. So here we go. We've got these standards. Now, on Tuesday, Monday and Tuesday, we did 6th grade. Wednesday, we did 7th grade. So here's the 8th grade. So here's what the 8th grade standards tell you that we have to do. It says that, 1, we got to write one variable equations or inequalities. Here's the inequalities with variables on both sides that represent problems using rational number coefficients and constants. So in other words, we got multi-step equations and multi-step inequalities with variables on both sides. And they're going to have rational numbers. So that means you could have decimals, fractions, regular plain old numbers, integers, you could have it all. Then you got to write a corresponding real world problem when given a one variable equation or inequality with variables on both sides of the equal sign using rational number coefficients and constants. Now when it says this, write a corresponding real world problem, well, you know the real world problem, you know what it means, don't you? Yeah, it means word problems. So that means you've got to, from a problem, pick which word problem matches it, or vice versa. Giving you a word problem, which equation or inequality matches it. And we'll get more into that as we progress through this. Probably more in the second half or the second time we do this lesson than the first. And then last but not least, we've got to model and solve one variable equations with variables on both sides of the equal sign represent mathematical and real world problems and rational number coefficients. So not only one variable equations, but also inequalities. Okay, so that's why we're having to do this. So let's dive off into a multi-step inequality. So write this one down for me real quick. 3x plus 5 is greater than x minus 8. Now Now what we're going to do in this first part of the video is we're just going to work a couple of these, and then I'm going to stop the video and I'm going to make a second video doing the rest of it. Okay, and that will be the video for tomorrow, because this is the first lesson of a 2-day lesson. Okay, so here we go. Let's see. Well, in an equation, I asked you to look for a couple things. With inequalities, I'm going to ask you to look for the same things. The first thing we got to look for is, do we have any minuses? And in this one right here, I do, so I'm going to change it. Now that second question I asked you to look for, that second thing I asked you to look for in 2-step inequalities, we can't quite do yet, because right now it's a multi-step. Okay, but once it is a 2-step, then we'll look at that second one. And that is the coefficient negative? Right now we've got two coefficients. We've got a 3 and we've got a 1. And right now they're both positive, but until I get them together, I don't really know what it is. Okay, so I got to get it down to one coefficient. So the first thing I'm going to do is I'm going to get this x over to be with that 3x. And we do it the same way we did in the equation. I'm going to start at the inequality, and I'm going to write x plus negative x, and we know each of those would have 1s in front of them, plus negative 8. And then over here I'd write 3x plus 5 plus negative 1x, or just negative x. And now I simplify. 3x and 1x, or negative 1x, make 2x plus 5 is greater than, over here my 1x's go away, and I'm left with negative 8. Now at this point, where I only have a single coefficient, now I can determine, is my inequality going to flip? And in this particular case, since it is positive, my inequality is not going to flip. So now for the rest of the problem, I just work it like normal. So now I move the 5 over to the other side. So 2x plus 5 plus negative 5 is greater than negative 8 plus negative 5. So my 5's go away, and I'm left with 2x is greater than, and negative 8 and negative 5 make negative 13. Then I divide by 2, and I end up with x is greater than. Now in this particular problem, you will also end up with 3 answers like we did on yesterday's problem. Okay, so in this one right here, one of the answers would be negative 13 halves, and that would be okay. Okay, the second one I would do 13 divided by 2, and we would end up with, another one would be negative 6.5. And then the last one that you could have is negative 6 1/2. Okay, so each of these numbers here would be perfectly fine as a solution to this problem. I need a value of x that is greater than negative 13 halves, or negative 6 1/2, or negative 6 1/2. All right, either way. But that is how we solve a multi-step inequality. And it doesn't look any different than when we were doing multi-step equations. You just got to pay attention to one thing. When you get down to this part right here, the 2-step, that's when we have to look at our coefficient to see if it's negative or not. Okay, so let's see if we can look at another one. Okay, here's 13x plus 8 is greater than or equal to 9x minus 12. So what I'd like for you to do is pause the video and work this one the same way we worked that last one. Okay, so let's find out how you did. So the first thing I see in this problem, I see a minus. So I'm going to change that. Okay, now, like I said, I can't do anything with my x's yet to determine whether or not I'm going to have to flip my inequality. I've got to get down to the 2 steps. So I've got to get all my letters together. So I'm going to move this 9x over to be with a 13x. Okay, so I write the inequality down. Then I do 9x plus negative 9x, which is what it takes to move it, plus negative 12. Then over here, I'm going to write 13x plus 8 plus negative 9x. And now I combine like terms. My 13x and my negative 9x go together to make a 4x plus 8 is greater than or equal to, my 9's go away, and I'm left with negative 12. Now at this point, I can determine if I'm going to have to flip my inequality. Is my coefficient negative? No, it's not. So I'm not going to have to flip my inequality. And now I just solve it like normal. So I move the 8 over to be with the negative 12. 4x plus 8 plus negative 8 is greater than or equal to negative 12 plus negative 8. And then 4x is greater than or equal to negative 20. Divide by 4, divide by 4, and x is greater than or equal to, and then negative 20 divided by 4 gives me negative 5. Simple as that. That's all there is to it. Okay, so let's see what this next problem is. Oh my. Well, if you remember that standard, it talked about rational numbers, and you're going to have to deal with some rational numbers. Okay, so here's one. So let's write this one down. 1/2 m plus 3 is less than 3/2 m minus 12. Now, just because it has the fractions, are we going to do anything different? No. We're still going to get our letters together on one side and our numbers together on the other. It's just we may have to deal with fractions. So in fractions, though, we're just looking for, since we're adding or subtracting them, we're looking for common denominators. Do I have them already? Yes, I do. I have them already. Okay, so let's start by taking care of the minus. I see a minus I need to look at. Okay, so I did that. So now I need to move this 3/2 m over to be with that 1/2. Okay, so I start here at the inequality. 3/2 m plus, now how would I move that? Good. Negative 3/2 m plus negative 12. It's the same thing. We're not doing anything different just because they're fractions. You could have changed that to 1.5, but not worth it because you've got common denominators already. So 1/2 m plus 3 plus, and then the negative 3/2 m that we added on the other side. So now we combine like terms. Now I've got a 1/2 and a negative 3/2. Okay, so when you put that together, you actually end up with negative 2/2 m. Well, what does negative 2/2 or 2 over 2 actually simplify down to? Simplifies to negative m. That is exactly correct. Okay, so this part right here actually turns into just negative m plus 3 is less than, then over here my 3/2 go away, and I get negative 12. Now at this point, can you determine whether or not my inequality is going to flip? Yes, you can, because right here you've got a negative coefficient. Okay, and that negative coefficient is actually a negative 1. Okay, so yes, we can determine it's going to flip. Okay, so that means if this is going to flip, I'm going to, right now it's a less than, so I'm going to turn it into a greater than. I'm going to put my little reminder down there in the bottom just to make sure I don't forget. Okay, so negative m plus 3 plus negative 3 is less than negative 12 plus negative 3. So negative m is less than, and the negative 12 and negative 3 make negative 15. Now I know that there's a 1 in front of that m. So if I were to divide by negative 1, on both sides, I'm going to get m, and then on the right-hand side, I'm going to get 15. But because I divided through by that negative 1, what's going to happen to my inequality? It's going to flip just like we said it was going to. So I need a value of m that is greater than 15. And that's all there is to it. Okay, now that's where we're going to end the video today. Now tomorrow, we're going to pick this up, work 1 or 2 more problems, and then you're going to have an assignment to work on. It's not going to be a very long one, but you are going to have an assignment. Okay? So, until tomorrow, I'll see you later.